Hello, everyone. This is From Chaos to Clarity, Structured Event Reporting in Rails. Yes, hello. Great to see everyone. Thank you for being here. My name is Adriana. I am a staff engineer at Shopify. I've been working with Ruby on Rails since I started at Shopify about 9 years ago in 2016. And I currently work on the Rails infrastructure team. This is my lovely team here at RailsConf in Philadelphia earlier this year. Our team is a part of Shopify's commitment to being stewards of Ruby and Rails, both internally and in the open source community. We work to ensure that Shopify uses Rails the right way and that Rails can remain the foundation of Shopify's tech stack for many years to come. One of the really cool things that I get to do on this team is we get to solve Shopify-sized problems and then work on bringing solutions to those problems back into the Rails framework. So today I'm going to be talking about one of said problems, and that is structured events. Events are a big part of any modern Rails app, providing critical information about what's going on in your application. At Shopify, we spent years trying many different approaches to structured logging and events. We knew that other Rails companies were facing similar things and decided it was time to evaluate bringing something into Rails itself. We spent the last year developing the structured event reporter at Shopify, rolling it out internally, and I am really excited to share that at the start of August, it was officially merged into Rails and will be available starting in Rails 8.1. Yay! My hope is that you leave this talk today equipped to begin using the event reporter in your own applications. OK, so on the agenda today, we will start by talking about what an event actually is. What does a structured event mean? I'll give you a brief history of how Shopify was handling logging and events. The bulk of this talk will be talking about the structured event reporter, how to use it. I'll show you some examples of how we're using it at Shopify for our events. And finally, we will look at what might be in store for the future of structured events in Rails. OK, so what is an event? To put it simply, an event is a named record of something interesting that happened in a software application. It is contextual, meaning that it includes information about what happened, when, and often where and why. Good events are semantic, meaning that they are easily parsed to extract common context. There are industry standards for semantic conventions. These establish a shared vocabulary so that everyone speaks the same language when describing their data. At Shopify, we follow OpenTelemetry semantic conventions. There's a link in the slides there for most of our events. Apps can also define their own conventions for domain-specific data. For example, at Shopify, we are an e-commerce company, so we have a standard shop ID field that shows up in a lot of our events to associate an event to a specific shop. So a log is probably what comes to mind first when we talk about events. Events might be kind of synonymous in your mind with structured logging. A log indicates that something happened in your app. Maybe we produce a log like the one above when a user logs in. There are several other types of observability events. For example, metrics, numeric measurements sampled over intervals. Spans represent timed operations, and traces are collections of spans representing the path of a request through your application. In this talk, we will primarily be talking about events as structured logs, but modern observability platforms like OpenTelemetry and Honeycomb consider all of these occurrences to be events. Apps also often emit business events, which can be used to do things like power dashboards, perform A/B testing, or to make decisions about the business. While observability events like logs, metrics, and traces are great for developers to use to monitor and understand their systems, business events are important for understanding business or product usage. These events may have more explicit schemas and include more context for data analysis. Let's talk a bit about unstructured versus structured events. So most apps in Rails use the default Rails logger for producing logs. If you've worked in a Rails app, chances are you've probably worked with the Rails logger and seen logs like these ones before. So the log lines that the Rails logger spits out are unstructured. They are essentially free-form text strings. This is great for manual inspection when you're working on your app locally. But this does not scale super well in production. As you add multiple processes or servers to the mix, logs can quickly become unreadable. Log lines from different requests can become intermingled. That's a little confusing. There's also no standardization on format, so it's hard to search the logs unless you know exactly what you're looking for. So this is not a great experience as a developer. If we take a look at that user login log from earlier, we can rewrite it in a structured format. Structuring the data makes it easier for machines to parse and for devs to query from a logging platform. From a semantic perspective, it's also easier to parse a structured log and determine what it represents. We can set strong conventions around how attributes are named and how the event data is shaped. This just isn't possible with unstructured logs. So we will talk a little bit about Shopify's history and kind of how we got to this point of wanting to develop the structured event reporter for Rails. So at Shopify, we were relying on unstructured logs for a very long time, surprisingly long given kind of our size and how many developers we have. This is a screenshot of a log entry for Shipify, which is Shopify's shipping application, back in 2020. As you can probably tell, these logs are unstructured and pretty hard to read. The shipping team was having to resort to crafting really complicated queries with complicated regular expressions like this one in order to be able to query Splunk and search the logs for meaningful data. This led a few engineers at Shopify to develop a structured logging gem called the canonical logger. It exposed a new logging method called log append, which would append structured data to a request log. And it would also set a bunch of extra metadata by default, things about the request, request information, the path, resource information, and performance metadata. So this is cool. We had a lot of apps begin adopting and using the structured logger. They were able to benefit from structured logs. But it was really hard to make this a standard within Shopify because it was essentially replacing the out-of-the-box Rails logging experience. So other apps were continuing to rely on the default Rails logger, or they were relying on their own bespoke solutions for structured logging. Even our core monolith failed to actually adopt the canonical logger, for reasons which I'm actually not entirely sure. We were continuing to use the Rails logger for logs in the monolith. And actually, core was still constructing this structured request log, but individual log lines were aggregated into a giant string under a payload key on that request log. So this meant that we were still relying really heavily on Splunk's ability to index freeform text strings in order to be able to search the logs for meaningful data. We were also emitting business events in our applications via a completely separate workflow. At Shopify, we built a system for schematized event production and consumption called Monorail. So events had to adhere to explicit predefined schemas, which included a name and a version and a set of typed attributes. For example, this is a schema for an event that is triggered when a shop is closed due to fraud. Within our application code, we'd call monorail.produce. You'd pass in the name of the event, the structured data, and it would emit an event corresponding to that schema. OK, so that's a little bit of our history. The problem, as you might be able to tell, is that we had a lot of different ways for handling events within Shopify. Even just within our monolith, different areas of the code base were inconsistent in how they sent data to consumers. We would send logs to Splunk, and those logs would be structured, but not really, because individual log lines were just being aggregated into this giant blob of text. Schematized events were being sent to Monorail. We were also sometimes sending data to statsd, or just writing it into the database, or sending it to some other bespoke eventing service entirely. And sometimes we would want to send the same data to multiple sinks, so we'd have to explicitly add all of these calls to send that same data to different places. So we kind of embarked on this journey to completely retool event instrumentation across Shopify. Our goals, first of all, to develop a unified API for all event data, including observability and business events. We wanted to eliminate duplicated calls to send the same data to multiple destinations. We also wanted to optimize for a faster search experience for developers. This meant structuring event data and emitting individual logs with clear names instead of aggregating them into a giant blob of text. And finally, we wanted to just generally improve the quality of event data. This meant using schemas for consistency and enforcing naming conventions. It also meant asking developers to audit their logs and remove ones that no one was paying attention to. And we decided that we wanted to build something in Rails, taking what we'd learned from developing the canonical logger and from working with logs in core. There were several things we had to keep in mind. The first is that the API needed to support different requirements for how an event's data structure is defined and enforced. This meant supporting both implicit and explicit schemas. What does this mean? Well, an implicit schema means that no formal schema definition exists. Consider our structured log example from earlier. The structure of the schema is inferred from the data. It's pretty flexible. An explicit schema, on the other hand, has a formally defined and enforced structure. The business event we examined earlier is an example of an explicit schema. We formally specify the shape of the event and validate that the data is correct at right time. Another requirement was that whatever we built had to be flexible enough to work with any observability stack or data pipeline. We couldn't make any assumptions about how data should be encoded or exported, or who might be consuming that data downstream. It needed to be generic enough to work, it needed to work with Shopify's kind of specific infrastructure that was already in place, while being generic enough to work with any Rails application. This meant separating event emission from how those events reach end consumers. And finally, we needed a good mechanism for annotating events with context. You may be familiar with the term wide event. With wide events, we dump as much information as possible under the assumption that this data may be useful later on. We wanted Rails to make it easy to accumulate all of this context and attach it to any events. So this brings us to the structured event reporter, what we ended up developing internally and upstreaming into Rails. So let's take a look at what the API looks like and how you use it. So the structured event reporter provides an interface for reporting structured events to subscribers. I have a link to the API docs there. It's available on Edge if you want to take a look. Now, at this point, you may be wondering, that sounds kind of similar to active support notifications. Very perceptive. While there are similarities between these two features, active support notifications and the event reporter are meant to solve different problems. So active support notifications is an instrumentation API. You instrument a block of code, and subscribers are notified when that block completes. They can perform an action or consume the instrumentation data, which includes things like the duration of the block, object allocations, et cetera. The event reporter is meant to be an API purely for reporting. So it's designed for telemetry and analytic events, meaning that it has dedicated features, for example, around things like context gathering and schematized events. Overall, these two features are meant to be complementary, and at the end of this talk, I will actually show you how we might use them together in Rails itself. OK, so back to the structured event reporter. It is accessible globally via Rails.event. So if you call Rails.event from anywhere within your application, you have access to the event reporter. We can call Rails.event.subscribe to register a new event subscriber. For example, here we have a log subscriber. It needs to implement an emit method, so that's the interface requirement for subscribers. The event reporter calls this method to send events to subscribers. And emit receives an event hash, which has a name, a payload, a set of tags and a context hash, a timestamp, and source location information. We'll get into those details in a second. OK, so when registering a subscriber, you can also specify a filter so that only certain events are sent to the subscriber. For example, our log subscriber might listen to only log events. Or we might have an audit event subscriber that matches against the event name and checks whether it starts with audit event. To report a structured event, we can use the notify interface. We need to specify a name for the event and the set of structured data. So in this case, user.created is the name, ID is the piece of structured data. You can pass in a payload hash, or you can pass in keyword arguments. Alternatively, you can also pass an event object, but we will talk about that a bit later on as well. OK, so after you call notify on the event reporter, it builds an event hash with the fields we talked about earlier. So it has the event name, the payload, which is the event structured data, so in this case, ID 123, has tags and context, which we will talk about later. And then it has when the event happened, represented in as a timestamp in nanoseconds, and where the event happened, provided as a file path, line number, and a label. And we emit that event to every subscriber. So let's again consider our log subscriber. What might it do with this event? Well, maybe it extracts the event name and payload and validates the data. Then it might encode the event, perhaps as JSON or another common data format. And finally, it might export the encoded event to a logging pipeline. This is actually a very simplified version of kind of what our logging subscriber at Shopify is doing. So yeah, this example, pretty simple. We're just validating the data, encoding it, and exporting it. But applications can customize subscriber code to fit their own use cases, infrastructure needs, third-party tooling around logging and events. For example, your log subscriber could aggregate events into a request log. At Shopify, we really wanted to be emitting kind of ad hoc logs in a structured format, but if you wanted to aggregate into a request log, that would totally be doable. You could also batch events and export them out of band. This is something we do at Shopify. You could also kind of handle failure scenarios, handle encoding failures, and send invalid events to a dead letter queue. So as we talked about earlier, one of our goals with the event reporter was to make it flexible enough to work with any observability stack or data pipeline. We implemented this subscriber pattern so that apps could maintain flexibility over how their events are processed, encoded, and exported. We wanted to separate the emission of events, which the event reporter controls, from how those events reach end consumers. One of our other goals was to support implicit and explicit event schemas. As mentioned earlier, the Notify API can take an event object instead of a name and a structured payload. For example, rather than passing user-created as an event name and specifying those attributes, you can pass a user-created event object to the event reporter. This object can be any Ruby object. Generally, it should represent a schematized event. Don't just go shoving any Ruby object in there. In this example, user-created event is a simple Poro, but you could declare a schema kind of more formally. The event hash the event reporter builds up will use the event class as the name, and the event object will be passed through the payload, which means that it is up to the subscriber to serialize the event object into a data structure that makes sense. For example, here we are calling serialize to turn that event object into a hash. So why did we kind of build the event reporter with this capability? Well, it was to support something we wanted to do at Shopify. So at Shopify, there has been a big effort lately to standardize on protobuf. Protobuf is a language-neutral data serialization format, that's a mouthful, developed by Google. So for us, we're using it as both a schema definition language and as a serialization format. This means that we define event schemas as proto, and then we encode them to proto-binary for transportation of events over the wire. So let's take a look at an example. Here we have a protobuf schema for an event in our monolith. This event represents a shop's plan changing. The proto defines the shape of the shop plan change event, including what fields need to be set and what they mean. Protobuf supports reading and writing structured data to and from a variety of languages, including Ruby. And it does so by producing generated code in the language of your choice. So we can compile our proto definition to a Ruby event object And then in our application code, we can just instantiate that shop plan change event with all of the required attributes and pass that directly to the event reporter. The event reporter then builds an event hash containing the proto object in the payload, like we just talked about. Since not all of our events at Shopify are schematized, we have a subscriber that listens only for protobuf events, and it does that just by checking whether the event payload responds to proto. And then inside our subscriber, we can handle serializing the event directly to proto binary format for transport over the wire by calling toProto. OK, we will finally talk about our third requirement for the event reporter, and that was making it easy to annotate events with all relevant context. Earlier, we talked about wide events, which means that when emitting an event, we want to dump as much context as possible under the assumption that that data may be helpful to us later on. So we designed two mechanisms for collecting context for structured events based on our needs at Shopify. The first of those is tags. So tags operate in a block-scoped manner and allow stack-oriented requests to all inherit the same set of attributes. Secondly, a context store. The context store is designed to hold request and job-level metadata that spans the entire execution context. So we'll dive into these two things a little bit more. So the API for adding tags is rails.event.tagged. So here, for example, we have an order fulfillment job, and we add tags to supply, for example, additional context about the order to any subsequent events produced within the block. Tags can have explicit schemas, so you can pass a tag event to the API directly, and tags can have explicit schemas too. The API for setting context in the context store is set context. So the context store is designed to store metadata that spans the scope of the unit of work. While tags are stack-oriented, the context store should be thought of as global to the scope of the job or request. It grows over time rather than acting as a stack. So we can call a set context on the event reporter to append a set of metadata to the context store. OK, slides are good now. Thank you. Here's an example of how we're using the context store at Shopify. We subscribe to an active support notification for the start processing action and use that as a hook point for setting a bunch of context on the event reporter. Things like the request ID, the ID of the shop involved in the request, the pod ID, which is effectively a shard ID, and the name of the database that we're hitting. And Rails will automatically handle resetting the context store around each unit of work. We do this by defining an initializer inside the active support railtie. So inside a toComplete block, which runs after an HTTP request or job finishes, we clear that context. So that concludes our overview of the event reporter. Let's quickly summarize what we went over. So we looked at subscribing with rails.event.subscribe. We talked about reporting events with rails.event.notify. We looked at the subscriber interface, which is emit, and an example subscriber. We took a look at event objects, and basically our use case for that in supporting schematized events. And then we looked at attaching context to events. Slides might have been a little confusing there, but basically we have tags for block-scoped context with rails.event.tagged, and we have rails.event.setContext for context that spans the execution context or the unit of work. OK, so kind of reflecting on those initial reasons that we built the event reporter at Shopify. Number one was developing a unified API for all event data in Rails. So in the Shopify monolith, we replaced over 11,000 calls to Rails.logger with calls to Rails.event. So all of our logs are now structured, going through the event reporter and not going through Rails.logger. We've also begun introducing schematized events with protobuf to replace our usage of monorail. These are also going through Rails.event. And we're working really hard to get rid of other eventing paradigms and to make the event reporter kind of the green path for structured eventing in our Rails applications. Number two was optimizing for a faster search experience for developers. So logs are now easier to query than before. since they have names and clearly defined attributes. And then 3 was improving the quality of event data. So we've vastly improved the quality of events in our monolith by requiring developers to structure their logs. We follow semantic conventions when naming fields, and we consistently attach as much context as possible to every event. All of this helps us to have a complete picture of what's going on in our Rails application. We will wrap up today by talking about what's in store for structured events in Rails. So a huge milestone for us would be to have structured events throughout the Rails libraries. Currently, we emit active support notifications at various points in the framework. If you're familiar with the guides here on Rails framework hooks, this is what I'm talking about. Things like a SQL query being performed, an active job starting or finishing, and action controller beginning to process a request. Rails emits hooks for all of these things. And Rails implements log subscribers out of the box. So they consume these framework hooks, format them into human-readable log messages, and leverage the Rails logger to output these logs. For example, Rails dispatches a SQL.ActiveRecord notification when a SQL query is performed. The ActiveRecord log subscriber then turns this event into a log. So we've begun fleshing out structured event subscribers, which would do something similar. Just like with the log subscribers, they would consume active support notifications and transform them into structured events, emitted via the event reporter. So earlier in this talk, we discussed kind of differences between active support notifications and the event reporter. This is an example of how they would work together, where ASN would be the thing that kind of instruments and produces those framework hooks, and then the event reporter is what reports on those events. Another idea is better integrating structured events with the Rails logger. This might sound a little strange, but let me explain. Many small Rails apps don't implement their own complex logging infrastructure. Apps might be using platform as a service and just like relying on standard out log capture. Or apps with self-managed servers might still be relying on those traditional log files for their logs. So these apps can and should still leverage, the structured event reporter, structured logging, but they may just want to turn those events into JSON and send them through to the Rails logger. So it would be really cool if Rails provided a subscriber out of the box that could transform events from the event reporter into JSON and send that to the Rails logger. Apps could then easily migrate to the event reporter API without having to hand roll their own subscriber logic. We could also make the development experience better by writing a subscriber to transform structured events into human-readable log lines. Developers are still really used to seeing human-readable logs like this when working on their app locally. It would be great to provide this without requiring every Rails app to write their own development-specific subscriber. So all in all, there's a lot of room to kind of expand what Rails offers here. Shipping the event reporter API, in my opinion, was really just the start. If you're interested in any of this, please come talk to me. I would love to have a chat. That is all. I hope that you've learned about the value of structured events and that you'll give the structured event reporter a try once it's released in Rails 8.1. Yay. I'd also like to give a special thank you to these fine folks at Shopify who were instrumental in helping to ship structured logging. And actually, my colleague George is going to be giving a lightning talk tomorrow, about kind of how we did this mass migration from unstructured logging to structured logging in the monolith. So definitely go take a listen to George's talk. Also, a very big thank you to anyone who took the time to review the PR upstream and left feedback. Super appreciated. Thank you all for being here and listening to me talk for 30 minutes. I'm Adriana. You can find me on X, or check out the Rails at Scale blog that our team runs to learn more about what we're up to at Shopify. Thank you so much.